fifth grade, how are you? I am well. Okay, good. We're all well, hopefully. This video is for next Wednesday, June 3rd, okay? And it is all of Module 3, okay? It's all of Module 3. So what I'd like to show you is this is a lot of information, okay? If you end up having to watch this video twice, it's okay. There's a lot of information on this board, okay? I pulled things from the teacher's edition, and I've also pulled some stuff from your student book pages. Just try to take it all in. We'll kind of go through, and I'll tell you later, there's another way of that I think might help you too, but we'll get into that in a little bit. So we're doing powers of 10, okay? So basically, that's 10 to the 1, 10 to the 2, 10 to the 3. Okay, and then, so what do I mean by power of? So exponent, a number or symbol that indicates the power to which the base number is raised. So I know you guys have seen these. I don't know how much you did, but 3 to the 2 means 3 times 3, okay? 4 to the 3 means 4 times 4 times 4, okay? Easy enough. So when we're doing, say 64,000 divided by 10, you know you just take a 0 off 6,400. But a lot of scientists would write it down as 64,000 divided by 10 to the 1. And then you take 1 0 off. Or if it was 64,000 divided by 100, you could also show that as 64,000 divided by 10 to the 2, which is 2 zeros, 100, okay? Part of the problem string for this section also started with 64,000 divided by 10 to the 3, so it was one more from that. But this was in the book as a problem string. So if you're dividing by 1,000, which is what 10 to the 3 is, you're taking 3 zeros off, so that's 64, okay? Now as we go down, remember, this is all 4.5, 4.5, 4.5, but then we've got 10 to the 1, which is 10, times 10 to the 1, times 10 to the 2, which is 100, times 10 to the 3, which is times 1,000. And you guys know for just 10, you move the decimal once, so it goes from 4.5 to 45. For 100, or 10 to the 2, twice, which is 450. 10 to the 3, it turns into 4,500. Okay? So then the book went down, the problem string was dividing by powers of 10. Okay? So we've got, now we're dividing by 10. So you remember, if you're dividing by 10 or 100 or whatever, you move the decimal however many spaces 10 gets, how many spaces 100 gets, and so on. So 2.7 divided by 10, or 10 to the 1, is 0.27, because it just moved once. Then if 2.7, if you move it twice, 10 to the 2, because 10 to the 2 is 100, you move it twice, it's 0.027, because it moved twice, okay? And then the last one, because we're dividing by 1,000, it moves 3 times. 1, 2, 3, 0.0027. And then the book just wanted me to show you this little pyramid. 100,000 equals 10 to the 5. Count those zeros, everybody, count those zeros. Look at 1 million, 6 zeros, 10 to the 6, and so on. So as you look at these, you can just see even 1 billion, 9 zeros, 10 to the 9, okay? So you can kind of see that pattern there. All right. So then in the book, it just mentioned these two equations right here. So we've got 0.40, and you also know that as, that's either 40 hundredths or 4 tenths, because they are equivalent, okay? But if you're thinking of for instance, a candy bar, you've got almost a half, right? Because 4/10 is almost a half, and you're dividing it into 100ths, okay? 0.01 hundredths. It's gonna get larger, okay?
You're going to have 40 pieces.
You're gonna have 40 pieces.
Yeah.
Out of that 4/10 or 40 hundredths, you're dividing it by 1/100th, and so you can have more pieces. Now that same candy bar, almost a half, times 1/100th, it's going to get really small. Those pieces are really small, and you have 0.004. So basically, when you're dividing by a number under 1, your number's going to get bigger because you're dividing it into a lot of pieces. When you're multiplying by a number under 1, it's also, rather than getting bigger, it gets much smaller. So when you're dividing, your dividend, which ends up being your quotient, your dividend ends up as the quotient being bigger. And here, your dividend, when you're multiplying by a number under 1, actually gets quite smaller, okay? So, if that's confusing, what might help as we go through these, if you're like, oh my God, I'm totally confused, take like 3 problems in the book, or even if your parents make 3 problems up, like 1.65 times 10 to the 2, something like that, which you know is 100. Do them by hand, like 3 problems, and then, do like, or maybe 4 problems, do 2 multiplication, 2 division. See if you can do them, and then check with a calculator. Check your answers. Because sometimes, even for me, when I was doing this for you, I pulled my calculator out a couple times just to make sure I was accurate, okay? So it doesn't hurt. Now, obviously, I don't want you to do the whole lesson with a calculator. That's not going to help you at all. But what we're trying for is understanding. And sometimes when you see the answer, you can go backwards and you're like, oh, now I see how they got it. So it's okay to use a calculator to check your answers and kind of, because what we're working on here is understanding. Okay?
Yeah, there's a lot going on here.
Yep.
Yeah.
So on this set, okay, the book, this is the teacher's guide once again. We have 450 divided by some number equals 0.45. So remember, the left side has to equal the right side. So what number divided into 450 gives you 45? Or 0.45, excuse me. Well, some of you are thinking, well, to go back, we'd have to divide by 1,000, right? I got a small space here, so I'm going to say 10 to the 3, right? I mean, that's 1,000, and that now the left side equals the right side. So over here, we have 450 divided by some number equals 4,500. Whoa, see? It's bigger. Over here, it got smaller, okay? We went from 450 to 0.45. Now it went bigger. This was divided by 1,000. This is divided by 1/10 to move that decimal over 1. Okay, and the last one, this one is real easy because you guys do this all the time. That's 10. You could do 10 to the 1 if you wanted to practice powers of 10. But 450 divided by 10 is 45, okay?
So is it okay for them to put 10 cubed or 1,000?
Yeah, this is either or.
Okay.
I didn't have much space, so I did 10 to the 3. But if they want to put 1,000 for understanding's sake, that's fine.
Good. Either answer is okay.
Yeah.
Awesome.
Okay, so here we have 450 divided by a whole 10. Okay. So how does the left side equal the right side? Okay. Well, this is going to be 0.1. Okay. So because they both sides have to equal 45. And for this side to equal 45, you're gonna have to multiply by 0.1 to bring that decimal back, okay? So the next one, to make it true, is 10. So 450 divided by 0.10, and then 450 times 10, you end up with 4,500, okay? And the final one, once again, I just thought I'd try exponents. We got 10 to the 2, which you know is 100, and if you want to put 100 for that, I'm just trying to get you guys practicing, okay? So the left side equals the right side, and this is times 100, so 45,000 equals 45,000, okay? And one of the last things I wanted to show you from the teacher's book is they did, split these up, okay? So they did 0.10, or if you want to call that 1/10 or 10/100, you know that, it doesn't matter, times 43, okay? Well, you know the decimal started here and came back one, that's all. So we got 4.3. All they did is double it, okay? All they did was double it. So now it's 2/10 or 20/100 times 43, 8.6. No mystery there, right? Then they did the same thing, but now it's 4.3 times 10/100 or 1/10. So the decimal moves back one more, 0.43. Then they went, what about 30/100 or 3/10? Okay? So if you triple this and the decimal comes back, it's 1.29. And you can always check those using your calculator and just kind of, you know, like I said, you're going for understanding here. You're going for understanding. All right, some of the last things I wanted to show you. This marker's running out. Let me try something else here. Okay, so can you show this real quick?
Sure.
289 and 290 is using the area model for decimals, okay? So the teacher's guide wanted me to show you 4400s times 4400s in an area model. So this is down. I know they're the same number, but this goes down. So you have 4/10, 400s, going across this one, 4/10, 400s. That, now your cube is made up, and now here's all your partial products, okay? Here's all your partial products after you did 0.4 times 0.4, 0.16. 0.04 times 0.4 is 0.016, same with this one, okay? Because they're the same thing. And then the real small one is 0.04 times 0.04, which is 0.0016. And then when you add those up, here's all your partial products. Add them up, and 0.44 times 0.44 is 0.1936, okay? So that's how you do that. I'm gonna get down on my knees here. The next one was, in the book, was 0.3 times 0.65. So this is just, you know, one number. So this whole side is 0.3, and we broke up 65/100ths into 6/10 and 5/100ths, okay? There's your partial product for this one. Here's this one. There's my plus sign. You're adding those together. 0.1, oops, don't want that there. 0.195, okay? And the last one, the book showed, is 1.2 times 0.63. There's your one whole. There's your 0.2. Here's your 0.6. Here's your 0.03 from this. See that? Here's all your partial products. Here's where it shows you added them together, okay? 0.756. But I also wanted to show you, because I know Toby's thinking, Mr. Barr, I don't want to touch that area model. I'm just kidding, Toby. I know you want to use this, which is the algorithm, okay? Remember, this is just a way of doing it. You also have the algorithm. So 0.63 times 1.2, when my fourth grade teacher, when I was doing these, or fifth grade, whenever it was, when you're doing the multiplication, when you're multiplying decimals, it doesn't matter how you set up. You don't have to line up the decimals, is what I'm saying. When you add and subtract decimals, you always have to line up the decimals, straight up and down, perfect straight line. When you're multiplying, you don't have to, because you don't need to know where those are till you get the final answer. So the way to do this, first of all, is pretend this is 63 times 12. So there's my first layer, there's 6, there's 12. We put our 0 because we're working on tens, put a 0, and then 3 and 6. Now, when you add them up, we get 6, 5, and 7. We go back up here. Where do we put the decimal? Well, all the numbers to the right of the decimal, you count those. So we got 1, 2, 3. So when we come down here, we have 1, 2, 3. That's where the decimal goes. So placing, do the multiplication first, just like you learned last year with Dr. Couture and myself. Do the multiplication first, and then add add up the numbers that are to the right of the decimal, and that's how many decimal spaces you move over. Okay? Over here, here's your work. Like I said, this is all Module 3. So anything that says Module 3, Unit 7, go ahead and do. I just listed here, if you want to look at these, 279 is the powers of 10, like we've been doing. 280 and 281 are using patterns of powers of 10. So those 2 pages, they give you tables, and they want you to look for patterns. 282 are a bunch of problems like this. 106 times 0.01, okay? That's 2 decimal spaces over, and that's 1.06. So they want you to practice those. And if you went to 282 first, let's just say you wanted to, because there's a bunch of problems like this, that would be a great page maybe to start with, and do that thing where I said try the first whole section by yourself, and then pull out a calculator and see how you did on it. That might be a good way of doing that. 283 is more exponents. 284, 285 are some more patterns. 287 and 288 are more powers of 10. And then the last 2 pages are what we did right here, the area models. Okay? So I know some of this is confusing, but you guys are so smart that I know when you're going into 6th grade, you'll remember parts of this, and you'll be like, yep, I'm pretty sure. I'll do a couple practice problems in 6th grade. Oh yeah, I remember. And remember this, some of you, maybe this is a total introduction to this, but like we said, try a few, check your answers with a calculator. We're going for understanding, okay? We're going for understanding. So anyway, I hope good luck on this. It's a lot to do, but as you know, it is a Wednesday, so I usually give you more on Wednesday than on Monday. So have a great weekend, and I'll see you next time. Bye.